Welcome back, episode 2. So now we are going to use same dataset with better workflow. So the idea of this video is we want to do less and we are going to log more with the help of auto logging and evaluation. We will add in the last episode you have seen we have done lot of manual auto logging. This time we are going to use we are going to run multiple random forest model training, each with their own config and with their own full pipeline, and we are going to actually track which part of dataset are being used for what model, and we are going to learn about MLflow evaluates. So here is the code. This time I have copied the some lines from here. This is some configuration that I have done so that we have switched the folders. Usually we don't do that, but I am trying to get the same reference to same artifacts and all. So let's start with the train sweep code. First thing first, let's also get the now for this we will change the experiment name as episode 2 and let's give it a name of autolog. Now let's read the dataset, and since we are going to use same pre-processing, so let's also take that code. And now let's enable auto logging from sklearn. So log input examples. Yes, we want to do log model, and let's make it silent. Let's prepare a small sweep of configs. So estimators, let's define one as 150, maximum depth as 10, so let's train different model with 300 and depth of 12, and let's define one with none depth. For now let's keep only 3. So now let's make a variable that holds the result. With MLflow dot start run Let's give the run name rf sweep. Parent as parent run. Let's give the dataset train MLflow data from pandas. Return as filetrain. Let's also first copy the train rest splitting. And after that, let's give the source give the name smartphone returned train and then we can do MLflow log input. Dataset train let's give the context as training. For now, let's print the error if any error occurs. Now let's iterate for each config. With MLflow dot start run and run name, let's define as random forest cf config number of estimators times config max depth comma nested is true. So these are the child run. Now let's build model from this random forest classifier. Number of estimator is config number of estimators max depth config and we can go with random state as random state job as -1 class weight is balanced, so CLF will be pipeline steps. First step is prep, where we are going to preprocessors. After that is the random forest, just the same thing that we have done. It's just we are running multiple nested. So now fit and evaluate. Train y train now let's calculate the accuracy score. Y predicted, and also let's get the F1. Same thing. So let's log the top line matrices manually, and so that we'll also know, because some matrices we wanted them to be always present. And let's F1 F1, and also let's MLflow set. We can set the tags this time. So let's give it the stage episode 2, model family, random forest. Let's give it one other tag, purpose. This is hyperparameter sweep. Now let's get the automatic. Same thing that we did for training. Now we are going to use MLflow evaluate. We'll pass the classifier. After that we'll pass data. After that here we have to pass the data frame. And then targets. Model type. It is a classifier. And we can define an evaluator. Let's use the default one. Let me check if everything is fine. All right. And if there is any exception, and so we will also append the results. So let's get them. This is CFG. I think this is done. Now let's try to run it. So to train sweep. So it is creating model. Okay, let's see if we get the auto sweep. It was successful. Look here, it is showing the data, all of the information. Now this is the parent one. Here you will see the child one. So if you click on this plus icon, now you will see everything, the tags that we have defined, the training scores, the preparation pipeline, and criterias, transformation. All of the information are being auto captured from here. Model matrices and the artifacts, precision recall curve, everything for all of the runs is available. Evaluation dataset is also, training dataset information is also available. So that's how you do proper experiment tracking with parent and child nested runs. Yeah, thanks.